two specific functions here. So let's start with this. Now, to do this, I'm gonna import. Oh, okay, before that, let's do an application without threading. I'm gonna create two simple functions. Count forwards from, let's say, start to end, and then count backwards from start or from end to start particularly. So count forwards is going to do a simple task. For I in range of start to end, I'll just print I. That's it. Count backwards will do the opposite. For I in range of end to start, and since we are going backwards, I'm going to add -1. I'm going to print again I. These are the two functions. I'm just going to call these functions. So if name is equal to main. Again, just a habit of using this to differentiate every other part of the code with the code that's supposed to run at the start of the program. That's why we're doing this, nothing else. Here, I'm just going to run count forwards 1 to 6, and then count backwards 10 to 5. That's it. Once you execute this, oh, I am so sorry. It's supposed to be, okay, 6 to 11. Um, sorry, 5 to 10. Because I'm taking this variable as start comma end, but here I'm reversing them. So one minor mistake, please ignore that. Let's take a look at this. Now, if you observe, I get 1 to 5 printed forwards, then 10 to 6 printed backwards. Now, you may not think this is a task that takes too much time. So to make it a task that takes too much time, let's import time. And for each print, I'm going to use time.sleep of 2. We're going to sleep for 2 seconds within this application. And I'm going to do the same thing even here. Now, if you run this application, we get to see and realize that this first function takes a lot of time, and only then second function gets to execute. If there were only a way to make sure both of them execute at the same time, that is what we're going to try to do. Let's take a look at this. There we go. This is how our program will execute essentially. Now, let's go on to the next part of this. And yeah, let's move on ahead. In our case, right, apologies for the delay. Yeah, in our case, let's go on to the next case. The next case here is instead of having this perform one after the other, let's parallelize them so that both of them perform simultaneously. That is going to be our next part of this task. So let's see how we can do that. To perform this, I'm going to import a package called threading. This is an inbuilt Python package or module that you have that can help perform this. Now, in threading, you have a class called thread. You have to create an object of this class. I'm going to create one object of this class for forwards function and another object of this class for backwards function. So we're not going to call the functions directly. Instead, we're going to make the threads call these functions. Let's call this as forward thread. And let's create another thread called backward thread as threading.thread. Now, within forward thread, I need to specify which is the function that we are calling and what are the parameters we are sending to it. So let's do that. Let's call the function and let's send the parameter. Now, to call a particular function, in threading, you just have to specify target. Target is going to be what is the function or what is the callable object? What is it that you want to run? In our case, we want to run count forwards here. So I'm going to have target equals count forwards. In this case, target will be count backwards. And you cannot write bracket and specify parameters here. Please don't do that. If you want to pass parameters, you have to pass parameters as a separate key called arguments. So please remember, argument is a list or a tuple of arguments for the target invocation. Default, it does not send anything. You should not call a function here. You should only provide the function name because the thread will call it later. That's why I'm not gonna add brackets here. Please note the difference. If I add the brackets, that means I am calling the function, not the thread. I want the thread to call the function later on. So I'm gonna specify arguments separately as 1, 5. And here I'm going to specify arguments separately as 6, 11, or you can write 5, 10, whatever it might be. Now, once we do this, let's see if this program so far runs without any error. If you run this, it just executes and does nothing. That's because we have created these threads, but we are not running these threads yet. To run these threads simultaneously, to start the thread, again, I'll just add a comment here. Create a thread by specifying which function the thread should execute with what parameters or what arguments. This is what we're specifying. To start the thread, I'm just going to use forward thread dot start and backward thread dot start. That's pretty much it. Once we run this, take a look at this. Your output is coming in such a way that both threads are running simultaneously, and instead of taking 20 seconds to run the program like it did before, it's taking 10 seconds to run it because both threads are performing their set of operations at the same time. That's pretty much it. So this is pretty much all we need to know in this and understand how exactly threading works. Now, moving ahead from here, let's go on to the next part of joining these threads. Prior to that, please let me know if you have any queries in this so far. I will go through and answer the same. If there are any queries whatsoever, please let me know. I'll help answer the same. All right. All right. So yeah. So no queries, I presume, so far, which means we can move ahead. Now, let's take a look at this. And let's try to work around understanding this. The next part of this is to know when the thread ends. To know when the thread ends, you use we use forward thread dot join. Now, join is a function that will wait until the thread terminates. This will keep waiting until the thread terminates. And after the thread terminates, the next line will execute. So the next line will be print forward thread has completed. So if you want to get to know the information that it has completed its thread task, you can do this. Then let's take backward thread dot join, and we're going to print, let's say, backward thread has completed. Now, to work around this, let's take a look at how this, sorry, to work around this, let's take a look at how this might help us. The moment this thread has ended, let's end these threads at different times. For one thread, we'll wait for 4 seconds, the other thread will wait for 2 seconds. Now, here's what happens. You will not get the output exactly as you expect, just so you know. In our particular case scenario, in our particular example, even though forward thread ended later than backward thread, if I'm not wrong, so time to sleep was 4, we still got backward thread has completed first. Sorry, forward thread has completed first. Here's a couple of reasons what we need to know. This logic is still linear. This logic is always going to be linear. It's going to wait for this first, then it's going to wait for this. So if you want to wait for all threads to complete and then provide a message, you can do that. If you think a particular thread ends early, you can add that first. So all these kind of operations you can perform just for your reference. This is how threading works. Very simple, no difference in functions. Just add the following lines. Create a thread for the function, start that thread, wait for it to complete, then continue ahead. This will help your code run in such a way that it performs the same operation or whatever operation is required with multiple CPU threads or multiple CPU cores, rather, not threads, sorry, multiple CPU cores rather. That will help out making sure that your code runs faster, especially wherever you can parallelize it. So a very good best practice and a tip of a Python developer, if you feel, hey, my app is running too slow, my app is taking too much time, I need it to go faster, think about it. Can I make it async anywhere? Or can I make it multi-threaded anywhere? And remember, you have to make it async under a certain condition. You can make it multi-threading if you have multiple CPU operations. Please remember, each if each thread will perform a CPU operation. If your idea is, I want one thread to wait for a response from a network and another thread to wait for a response from some database, both of them still wait, then it won't help. So the idea is that whenever you have CPU intensive operations, where you need to use a lot of CPU power so that you can make use of multiple cores simultaneously and it can perform some operations like image classification or some machine learning operations or whatever it could be. Again, machine learning, we expect it to perform in GPU, so please don't compare it to that directly. But whatever operation that requires a lot of effort with CPU, you can try this out. Async is where you have only one thread, not two threads. And when that one thread is waiting for some output, it'll go perform other task and then get back. If there is no other task to do, async is pointless. So async helps when you have many tasks to be performed, many requests will be sent, many operations are to be done. The same operation has to be done 100 times and you are sending 100 requests, then async will help because many of them will have wait. So those processes will do other tasks. However, if it's CPU intensive, async will not help. Async will help only when it's network bound. If it is CPU intensive, async will keep working. It will never wait because CPU intensive. It keeps accessing CPU. It keeps working. So multi-threading helps when it's CPU intensive. Async helps when you have a lot of input-output operations or network-bound operations. That is a big difference that we need to know just for our reference. So please note this and please remember this for our reference at least. So I'll just point this out. Multi-threading helps with CPU intensive operations, and async helps with network bound or input output bound operations. So now that we know the idea and the difference between these two, specifically multi-threading and async, let's go on to the next part of this. Let's go on to the next thing, right? So we have covered quite a lot of things already. We have covered quite a lot of uh, parts of Python that we need to start from basics. Again, I'll just point out the remaining things that are left within our case to work around. Create customized exceptions. This is a fairly straightforward thing. We'll work around this later. We still have regular expressions to work on. Followed by this, we still have pandas to learn and database connectivity. And if time permits, we're going to take a look at a few things as per the request of the participants, that is Selenium and machine learning model building, evaluation, and so on. Again, I'll be honest about the time constraints we have. We will see, depending on the time constraints, how much we can work around these, how quickly we can work around this, and we will work around it accordingly. Now, one question before we move ahead, just as a query so that I get to know this from all the participants. Again, on a scale of 1 to 5, I know there are a lot of people in this group that particularly work on data analytics and data science. So you will be well versed when it comes down to this. But apart from that, just out of concern to make sure that I know where to start from, it's totally fine, whatever the answer might be. What is your current expertise on pandas and polars? You can let me know. It's fine if it's greater than 5 or lesser than 1 as well. So that is absolutely cool with us. So any response would be absolutely helpful. Right. So we already see a wide, um, diverse difference when it comes down to this. And I understand that because I completely get the point of the participants where some of us are already well versed with certain things and some of us are kind of new when it comes to certain things. So that is something I totally understand. So what I will try to do is when we look at pandas in our case, I'll try to cover it purely from a perspective where we can learn it, understand it, and work with some possible application on top of it so that we can see a real world application and use it simultaneously. So that is pretty much what we are going to try to do. So that's going to be our main purpose. So to do that, I'll just share a particular data set. I request all of you to just download this data set because we're going to try to work on this. And we know a lot of things that we have already done, and we're going to use that to work on this data set. So let me just search around the data set and share this to you guys. Right, so this is pretty much it. So I'm just gonna do one thing. Um, I'm gonna download this so that I can share this with you all, so you can directly get to access this from my end. So I'm just creating a directory called o6 underscore pandas. I'm going to go to that. Uh, this is the only thing we need. We don't need anything else. We're just going to try to work around these queries completely by ourselves. So that's what we're going to do. Right. So I think it's because of the get. That's fine. Let's leave it at that. So this is the data I need you to have. I'm just going to share this across the drive. So we have access to this. So there we go. We have it in this particular directory. I'll share this directory just in case. It's not necessary that we need this immediately within the next minute or two. Even if you have access to this within the next 15 minutes, it's fine because we'll take a few minutes just to understand um, why we need pandas, what functions we have in pandas that will help us. And once we do that, we immediately will dive deep into this. That's the whole point. All right. So let's go ahead and begin with this to begin with. Now, first things first, we have learned one very important point about Python, that is, list is inefficient. Remember, a list can store multiple data types. As we know, a list can store elements of various data types. This makes it very large in size compared to C or C++ or Java programming language styled arrays. This is one thing that we have differentiated from. The advantage in C, C++ or Java type arrays is that you will have an array of elements that you can store. And this entire array of elements, whatever you can store and whatever you can work on, will be very small. And because it will be very small, uh, and sorry, the reason it will be very small is because it can store only one data type. We have looked into this in detail as to why it only stores one data type and each element takes the same size, which means we can move to any index very quickly. We have observed this before. So for instance, if each element takes 4 bytes, the first one starts from 100, then the next from 104, 108, 112, and 116. Let's assume this is index 0, 1, 2, 3, and 4. If you want to access fourth element of an array, you just need to take the starting index and add 4. But before adding just 4, you have to multiply that 4 with the size of each element. Size of each element in our case is 4 bytes. So we're going to multiply that 4 and we're going to get 100 plus 16, which is going to be 116. And that's how I'll access index 4. This is how indexing works. This is why the first element of index is always 0, because when you add 100 plus 4, which is the size of each data type, multiplied by 0, you'll get back 100. And that's how you get the first element of an array. And this is the logic because of which indexes or indices of array begin with 0 always. That's the first thing. Now, here's the problem. Here's the advantage and disadvantage of this compared to list. In list, you can store elements of different data types. Because you're able to store elements of different data types, you don't know what could be its size. So instead of storing random size data types, what list does is it stores the following information. What is the data type? That is, it could be string or int or whatever it is. What is the size of it, length of it, and where is it stored? Starting address could be 900 somewhere. So if you go to address 900, you will get that particular string. Each one of these, let's say it takes something like 8 bytes. I'm just giving a random number. If each one of this takes 8 bytes, it's going to be 100, 108, 116, 124, and so on. Now, consider this. If I access list of 3, it will go to this index because it knows this address. From this address, it will take starting address. Let's say it is 990. It will then take this starting address, go to address 990, and then get you the value. You see the number of operations it performs, 1 and 2. Whereas in arrays, it's just one operation. You can see it's faster already. Second, since it doesn't have to do all of these additional tasks and additional storage, its size is also lesser. The only problem is it cannot store data, uh, it cannot store elements of multiple data types. And we don't need that in many real cases. Think about this. Let's just think about this. Let's assume there's an Excel file or there's a CSV file in which you have the following: a column called quantity. This column called quantity is going to have only numbers. We know that it's only going to have only numbers quantity like 1, 2 quantities, somebody ordered 10 quantities, somebody ordered 20 quantities, and so on. There might be other rows and columns. I'm not worried about that for now. I'm only concerned about quantity. When I take quantity, I can take it in a list or I can take it in a C language type array. When I take it in a C language type array, it's going to take lesser memory and it's going to be faster to access things as well. That's why C type arrays or C language arrays are used a lot in Python because lists are inefficient. They're easy to use, but for these kind of operations, they're inefficient. So whenever you want to use C type arrays, we go ahead and we import or we utilize a particular package called NumPy. NumPy is a package that allows C language type arrays to be created and utilized. As you see here, the core of NumPy is well optimized C code, basically the same thing. It allows you to use the arrays that you literally have in other programming languages like C and C++ within Python. That's the advantage of it. Now, since we realized what it does, let's go ahead and learn how it works to begin with. First things first, in our case, the idea of NumPy arrays or NumPy to work around is to first import that package. Now, for this purpose, instead of working in a Python file or a Python um, file, okay, I think should be deleted, should not be a problem. Okay, there we go, this is done. So now I'm just going to create a new file here called um, numpy.ipynb. IPynB are basically interactive Python notebooks where you can execute cells of code one after another. And this is especially useful because you can see the output of each cell right there, right then and there, before going ahead to the next one. So the first thing I'll do is add a markdown. A markdown is basically a text which can differentiate a bunch of cells with a bunch of other cells. So that's one thing that we need to know. We need to differentiate our first cells with the second set of cells. The first cell is NumPy basics. So you have hash. You can use a single hash, double hash, triple hash. Um, to identify different size. If you use triple hash, this is going to be the size you get. If you use double hash, this is going to be the size you get. If you use single hash, it's going to be the largest size. I'm just going to use triple hash and I'll start and I can add a code here. Let's just add a code where we import NumPy and we use basic environment, the one that we have. Now, in case you don't have NumPy installed, you can either install it in terminal by using pip install NumPy, or you can do it within the cell as well by adding percentage pip install NumPy. It will perform the exact operation that will happen in the terminal, except within a cell. This will be in um, the terminal here. And yeah, we see that the requirement is already satisfied. We already have NumPy, so we don't have to worry about it. Pressing Control and Enter together will run the cell. Pressing Shift and Enter together will run the cell, and then it will go to the next cell. If there is no next cell, it will create a cell. And when we keep typing a lot of code and commands, it will help us. So these are the basics of, let's say, interactive Python notebooks that we need to know. So with that, let's go ahead and begin towards this. Now, whenever we start working on NumPy arrays, how do I know that it's faster than lists? Like, all right, sure, Jenny, if you're able to see this later on, right? So yeah, moving ahead back to this case scenario. Let's take a look at our current case. I can run this NumPy data or NumPy arrays, but how do I get to know it is much faster than the typical lists? The best way to do that is to compare them. So let's put them head to head in a simple operation. Here's what I'm going to do. I'm going to import time because we need to calculate time, right? Then I'm going to import NumPy as NP. We're not just going to import NumPy. Most of the times we're going to import NumPy as a short form of it called NP so that we can basically perform these operations in a much faster rate. So we can just write instead of writing instead of writing numpy dot array or something, we'll just use np dot array. It's similar to how we shorten a print to IC that helps us, kind of similar to that. Anyway, let's move ahead and try to work around the next thing.